Hey, Beard here. Let's talk about optical illusions. Now, they're kind of misnamed because it has a lot less to do with the optics of your actual eye and has a lot more to do with how your brain actually processes information. Let's take a look. Now, an example would be something called the Stroop effect, discovered by a doctor by the last name of Stroop. Stroop is really a simple exercise. We have a series of colors here, and you can see that they are actually not corresponding to the color that they are. So the exercise is simple. I want you to actually say what color it is without reading the word that's actually written down. Go ahead, I'm going to give you 20 seconds, see if you can get through it. Ready? Go! A lot harder than you thought it was going to be, wasn't it? Well, think about this. Here's the thing. The right side of your brain is really trying to say the color, but your left side of your brain really insists on saying the word, and so there's essentially some interference being run between the right and left hemispheres of your brain, and this interference really slows you down when you start to read these words. Your brain, it's amazing. Let's do some more. For instance, take a look at these two cards that I have here. Now, you would take a look at these and you would naturally assume which one is the larger. Right, most of you would point to the right one as being the larger, but you're being deceived. Your brain is actually deceiving you a bit. We'll take this card and you'll notice that it is a perfect match to the other card. What's happening here? Well, your brain, when it processes information, it does it in different ways. In this case, what it's doing is it's comparing the two edges which are closest to each other. And of course, this edge is slightly smaller than this edge, but you can see that when we put them together, they are in fact the same shape. Okay, let's take a look at another one. Look at this. We have these lines and we have these quadrilaterals in here, and as you look at it going this way, do those lines appear to be straight to you? Well, I know to me they appear not to be straight, but it's our mind deceiving us. You can see that actually these are, in fact, straight lines. Okay, take a look at this. Who is it? Mona Lisa, right? Does it look fine to you? Well, of course it does. Well, let's spin it around and let's see what happens. Does it still look fine to you? Yeah, I don't think so. Now, this is called the Thatcher effect because the original picture was in fact of Maggie Thatcher, the former Prime Minister of Great Britain. You can see this picture looks normal, but then when we make the turn, you can see that there's something desperately wrong with Maggie's face. The reason our brain is not very good at processing pictures which are upside down. But here's the funny part, it thinks that it is, and so it actually processes the information and tries to tell you that, well, it's perfectly fine, when we can see that it's actually not fine. Your brain is good, but it can be deceived. Now, this image has two images actually superimposed on one another. The first is physicist Albert Einstein, and the second is actress Marilyn Monroe. Here's what's happening. The details on Albert Einstein are much more distinct, whereas the image of Marilyn Monroe is sort of blurry. So from a distance, your brain processes it as the actress Marilyn Monroe, but as you get closer, you begin to see those distinct details, which brings out Albert Einstein. By the way, if you saw Marilyn Monroe the whole time, you might want to go to the doctor. You need to get your eyes checked. Science. So remember, your brain is amazing, but it can be tricked For instance, I'm not really here.